Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, let me start with a hot take. Encoder-decoder models aren't outdated. They've just been misunderstood. And T5Gemma 2 might be the clearest proof yet. For the last few years, decoder-only models have dominated everything. Chat code agents. They're simple, scalable, and powerful, but there's a trade-off we mostly ignore. They're not great readers. Long documents, structured inputs, images plus text, all of that gets squeezed into one stream. Encoder-decoder models solve that. They separate reading from writing. The encoder fully understands the input bidirectionally. The decoder focuses on generation. The problem? They've historically been heavier, slower, and harder to adapt from modern checkpoints. T5Gemma 2 fixes that by doing something clever. It starts from a pre-trained decoder-only Gemma 3 model, then adapts it into an encoder-decoder using UL2 pre-training. Same weights, different roles. You don't train from scratch, you rewire. Here's the core idea. The encoder is dedicated to understanding. Text goes in, images go in too. Images are processed by a frozen SIGLIP vision encoder, turned into 256 visual tokens, and fed only to the encoder. Everything in the encoder can see everything else. Full attention. That's huge for documents, charts, forms, or long prompts. The decoder then generates text autoregressively, but it cross-attends to high-level encoder representations. So instead of rereading the raw input every token, it queries a compressed semantic memory. That's one reason long context performance jumps so much. And this is the wild part. Even though T5Gemma 2 is pre-trained on sequences up to 16K tokens, it generalizes to 128K context surprisingly well. Benchmarks like Ruler and MRCR show consistent gains over Gemma 3. That's a structural advantage, not a data trick. Now let's talk architecture choices. First, tied embeddings. Instead of separate vocab embeddings for encoder and decoder, T5Gemma 2 shares all of them. Input embeddings, output embeddings, softmax weights. You cut about 10% of total parameters with almost zero quality loss. That's basically free efficiency. Second, merged attention. Normally, decoder blocks have self-attention, then cross-attention. T5Gemma 2 merges them into one joint attention operation. Keys and values come from both encoder and decoder states. Queries come from the decoder. One attention pass, shared weights. This narrows the gap between encoder-decoder and decoder-only designs, making initialization from Gemma 3 much easier. There was an attempted optimization that didn't work so well, applying cross-attention only on global layers. It saved compute, but caused a noticeable quality drop. Pitfall number 1. If you want strong performance, cross-attend at every decoder layer. A practical tip if you're choosing models. If your workload involves long documents, multimodal inputs, or retrieval-heavy prompts, encoder-decoder models like T5Gemma 2 are worth serious consideration. They're not just smaller alternatives. They're structurally better readers. So the takeaway, decoder-only models are great talkers. T5Gemma 2 proves encoder-decoders are better listeners. And for the next wave of long context and multimodal systems, that difference matters a lot. If you found this helpful, hit like, subscribe, and comment which agent system you want to build next. Stay sparked. See you in the next video.